This is TechStrong TV.
Welcome to TechStrong TV. I'm Bonnie Schneider. Today we're unpacking innovation with Jay Yu, founder of NANO Nuclear Energy, and CEO James Walker. NANO Nuclear Energy is reshaping the energy landscape with their novel portable nano nuclear reactors. Let's delve into their technology and its implications for sustainable energy. Jay, James, welcome to TechStrong TV. Great to have you here.
Thank you for having us.
Hi, Bonnie.
My pleasure.
Good to be here.
Wonderful. Well, Jay, having a background in finance, what inspired your shift to nuclear energy and led you to the inception of Nano Nuclear Energy?
So it first started when I wanted to focus a portion of my portfolio investments into agricultural tech or green energy. And the more I looked at the green energy aspect, I looked at wind, I looked at solar, and it wasn't much innovation there. But nuclear kept coming up. This small nuclear idea kept popping up, and eventually, I was reading more on nuclear and also the net zero government policies that are coming up. And without nuclear energy, I just felt like it was impossible to reach the net zero goals for these governments. So that's why I got started with, I founded Nano Nuclear.
And that makes sense, and it definitely has been in the news lately about nuclear is definitely top of mind. James, with your extensive experience in the nuclear industry, how would you differentiate Nano Nuclear Energy's vision and technological approach from others in the sector?
I would say the main way that we differ from other companies is that we started with the market. So we actually examined where the most use of nuclear energy could be deployed. So we realized that it wasn't actually the SMRs, which are a little bit bigger, it was the microreactors. So when you go really small, then remote habitation, remote industrial projects, mining projects, remote oil and gas, military bases, desalination plants, energy systems, even shipping vessels potentially. The market was potentially infinite. It would potentially unlock trillions of dollars in resources that can't be accessed because it's not economic to run them on diesel currently. And anything that uses a diesel generator anywhere, it could potentially be replaced with a nuclear battery that runs for 20 years. And we came at it from that angle, and that's really how we differentiated ourselves at the start. Jay sought out the best scientists in the world, and this was the modus operandi that we gave them. Has to be portable, has to be very small, has to be able to be transported by conventional transportation infrastructure, trucks, ships, trains, be able to get this anywhere in the world. And we came at it from that angle rather than starting with the tech and working to try and find a market.
Well, that's interesting that you mentioned the portability, because one of Nano Nuclear's striking features is the portability of its reactors. Can you discuss the advantages and the challenges that this mobile approach takes with nuclear energy?
So I think actually one of the big advantages that fell out of going very, very small is that you can actually create something that's incredibly simple. So you can remove almost all the working parts. It becomes intrinsically inherently safer as well as you remove working parts. And it becomes cheaper to manufacture, easier to transport, and even for deploying to sites, large commissioning and decommissioning times become unnecessary. That's the big one. Those are the big advantages that fall out. So it really does become smaller, cheaper, and safer when you get into this kind of realm. Disadvantages of the reactor is that no one's done this before at this kind of scale. It's been designed, but and the technology does exist, but no one's taken this up to the prototype level.
Well, that makes sense. I'm glad that you mentioned safety. That's always the first thing people think of about nuclear energy. But I know that the design of the microreactors ensure the containment. Can you talk a little bit more, both of you, a little bit about that safety perspective?
Sure.
Yeah, I could. Let me jump into this, Jane. As an average Joe who doesn't know, I'm not a nuclear physicist like James. So that was one of my first questions to James is, One of the questions we get asked a lot from investors or from the public is, can this microreactor on a truck, can it be used as a dirty bomb, right? Or can it be used as a staging point for terrorists? And James, what was your answer to me?
Well, if you wanted to try and make a bomb out of it,
Like a simpler one. You don't have to get into scientific details.
Yeah, you'd have to take the reactor apart. You'd have to liquefy the material with billion-dollar facilities to liquid it down. Then you need a massive enrichment facility, which doesn't even exist at the moment, to concentrate the fuel, then to reformat it into a workable. It's impossible. You can't. That's not how it works. But there's a lot of, obviously, I think nuclear suffers from the worst PR ever, given that it's safer than wind, it's safer than coal, it's safer than pretty much everything. It's the second safest form of energy out there, including solar, wind, everything, geothermal. And that needs to be communicated to the public. Even our reactors, once they're built, they will be able to passively look after themselves. So they could be completely neglected, and there'll be a self-regulating system built in where it's completely safe and we can leave them alone.
That's interesting. And I think that does bust a lot of the myths that are out there that you were saying about the bad PR. How does Nano Nuclear Energy's approach fit within the broader context of energy transition and the global push towards decarbonization? Obviously, everyone's interested in that, but our audience the TechStrong world are very interested in reducing emissions when it comes to IT usage, data centers, things like that, which tend to be a big user of energy. So how do you see the way nuclear energy fits into that decarbonization?
Just to reinforce what you said, Bonnie, data centers, all these Bitcoin mining data centers, the ideal source for carbon-free energy solutions would be Nano Nuclear's microreactors. Our smaller one is called Zeus. Zeus will be able to come in and power a data center and provide this carbon-free electricity for these Bitcoin miners. For example, we've been approached by a few actually that wanted to do a partnership, but again, we're still early on and we're still designing our reactors. But just to hand it over to James, I think remote habitations, data centers, military deployment, and also natural disaster relief areas. Like, for example, there was a hurricane in Puerto Rico. It wipes out the whole electrical grid. We could come in with Zeus and power up to 1,000 homes carbon free. So that's the disruption we're trying to create here for helping the earth and helping to step away from fossil fuels.
Yeah, just to add on a few other things, remember what Jay said. If we're serious about electrifying transportation, so we're going through the electric cars, or formatting the country for that to incorporate all electric vehicles, power stations throughout the entire country would suddenly be possible with these remote reactors. So you can't, in remote locations along highways, you can't just bring in batteries on a daily basis to create that charge for these stations. But microreactor anywhere along any remote location could provide a power station for any electric vehicle anywhere in the country at any time that would operate for 20 years. So it enables that ability then. And big industries like the shipping industry, which currently run on enormous amounts of diesel, those could all be replaced as well with nuclear power, in the same way that currently the US Navy and the US submarine all run on nuclear power in exactly the same way.
Yeah, I mean, that makes sense.
Oh, sorry, go ahead, Bonnie.
No, I was just thinking about when we're talking about renewable power, sometimes wind doesn't do it all or solar doesn't do it all. It's hard to get everything to work at the same time. So if you're looking at a microgrid and if they want to lean into nuclear as one of the solutions, how does that work when you're working with a hybrid energy system that might rely on multiple sources, including all types of renewables and maybe nuclear as well?
So certainly the solution for the future will be a multi-energy system grid. So it's going to have geothermal. When you have big countries, say like, for instance, America, it's going to draw on whatever resources it has available. If it's got geothermal, if it's got good wind, if it's got good solar, it'll draw what it can. The advantage nuclear has is the capacity factor of it way wind or solar, which are subject to sometimes there's no wind, sometimes it's nighttime, sometimes the power that you need to draw down is greater than the energy that you can extrapolate from the sun at the time. Nuclear can consistently give you what you need when you need it. And so it has to be part of the solution if you're talking in terms of zero emission solutions for a country.
That makes sense. And
An increasing part of the energy infrastructure in the country. And we're seeing that already with a resurgence in interest and demand for nuclear, as people gradually accept that you can't go completely renewable without jeopardizing your energy system. So like a country like Germany, they went in that route, shut down their nuclear. They tried to go more wind and solar. And the consequence was they burned more coal, or they had to buy French nuclear. And as good as your intentions are, you need to have that stable power source, and that stable power source, if it's zero carbon, is nuclear.
That makes sense. What about the advancements in AI and automation? That's something that we cover here at TechStrong a lot with digital transformation. How has that automation influenced the design and operation of your nuclear reactors?
I think it's going to play a big deal in the tech side too. We're planning to remotely operate these nuclear batteries, you could say, and on a truck, and obviously having fewer engineers there and controlling everything from a central hub. So AI will play a big part where it'll trigger certain factors like safety. For example, what you mentioned, safety is very important. So if something overheats, we can incorporate the AI technology to recognize heat temperatures. Maybe it's off on one area, so then we'll be able to shut it down from a remote location. So automation and also material science, right? As we continue to graduate into greater technologies, making chips smaller, quantum computing, I think this is going to be very key for advancing our technology as well, and also to incorporating that in the future.
And we mentioned some of the other applications of nuclear power, but I'd like you to discuss the potential of the technology in non-electric applications such as district heating, water desalination, and also hydrogen fuel production, another thing that's in the news a lot.
I think it's important to know that with nuclear, I mean, the first form of energy that's generated is heat, and the electricity is the conversion of that heat into that electricity. So you can create with microreactors large temperatures which are very perfectly suited towards hydrogen production. So say, for instance, if you have an operation or a remote location and you don't need to extract as much electricity at a certain given time, it's nighttime or it's low energy hours, you can create hydrogen production. And you can do that with the same power that would be going into the grid at higher usage points. That's going to be a major development in hydrogen power, because currently there's not a lot of technologies where you get up to that more efficient high temperatures that a reactor is very capable of producing. That's going to feed into more green solutions too. And even if you were looking to electrify cars using hydrogen production, this could again feed into that sort of charging station. You could generate both the electricity and hydrogen power.
Okay. Well, Nano Nuclear has an ambitious goal of powering over 500 homes per reactor for 20 years. Can you shed light on how you plan to achieve this, and what are the implications for global energy access? Jay, do you want to take that?
Yeah. So again, when we started this designing process of our reactors, we wanted to focus on something where it could disrupt in a remote location. One of the areas me and James were investors and we were comfortable with is mining. So there's a lot of mining operations across the world where the lifetime of these mines are usually 20 years. So it actually fits perfectly to that. And the way we designed this from a tech side, well, James could actually take this from more of a technical side, is we were able to model this, and the output of our Zeus, we're modeling for 1.5 megawatts. So if you do on average the household, that's where we derive the up to 500, or even sometimes, depending where you're at, up to 1,000 homes, right? James could talk more about the technical side if you want.
Yeah, mining was we identified very quickly, it utilizes a lot of diesel. Millions of dollars, some of these big projects, tens of millions of dollars of worth of diesel needs to be shipped in on a daily basis. And potentially, it not just makes these mining operations more economic to have a power source that's consistent and you don't need to ship that diesel in, but it'll actually make tens of thousands or hundreds of thousands of mining projects more economic. So it releases enormous amounts of resources to people generally. And it's not just North America that will benefit, but take a continent, large parts of the grid, the locations that are removed from the grid. This could open up enormous mineral wealth to some of those locations as well, where you could then start remote habitation, desalination plants, energy systems for homes, and power to power these remote mining operations and remote industrial projects. It could really unlock enormous amounts of wealth having this.
That's great, which kind of leads us into our final question. What is next for Nano Nuclear Energy? What are we looking forward to seeing in the coming years?
Sure. Thank you. I'll take this first. We're working really hard. We were featured actually on American Nuclear Society, which is a big think tank magazine and organization in the U.S. We were featured in their nuclear news with their editor-in-chief, and one of the the title was essentially a new company to look out for. So what they said about us was how aggressive we are. Me and James, as you can see, we're not 80 years old. We're very strong, young men, and we're aggressive with how we're approaching this too. We're approaching this from a capital market side. We have very high level investors. For example, our seed investors are the former C-level executives of the largest transportation company in the world. So having strategic investors is very important that share your vision. One of the reasons why they invested in us is they saw that we could be on a truck, on an ISO container, and they said one day if you get it commercialized, we'll know exactly how to ship you across the world. So that was a strategic investment, and we continue to look for strategic investors. Another part of this is when you think of nuclear, you have to attach yourself to government. So we've attached ourselves with many former government politicians and people joining us because Capitol Hill right now has pretty much a mandate to go to. They have a net zero goal, right, in 2050, and to get to that goal, you need to include advanced nuclear technologies. And just last week, the Advanced Act was passed by a bipartisan bill of lawmakers, and now it's going to go to the full Senate for approval. So the Advanced Act, we are the poster child of that, of a made in America nuclear tech company that is advancing carbon-free energy solutions, and also to help us with the regulatory aspect too, the hurdles that have plagued the U.S. throughout the many decades, and helping us to incentivize us for the future. That's key to where we're heading. So we're including the government. We're keeping very transparent and openness with the public, and having the best scientists, in our opinion, in the world, or a technical team, is very important to give credibility to Nano. James, do you want to add anything else? Well, maybe on the technical side.
I think just to complement what Jay is saying, is like, obviously we're confident we're going to produce the best reactors in the world, but we don't want to be limited there. There's enormous potential in the nuclear industry at the moment. It's the fuel side of things. We want to start consultancy services that we can farm out to other companies and assist them too. Transportation of material. There's all these very large areas that are open to business. And with the resurgence in nuclear, that we're examining being a fully vertically integrated company from the ore all the way up to power itself. And we're looking to be involved in every aspect of that supply chain.
Great. Well, thank you so much. J.U., founder of NANO Nuclear Energy, and James Walker, CEO. We appreciate you sharing your time and insights today on TechStrong TV. We'll be following NANO Nuclear Energy. Thanks, gentlemen.
Thank you so much, Bonnie.
Great. Well, stay with us. We're going to have a lot more coming up on TechStrong TV.